Hello, everybody. How are you guys today? Hello, everybody. How are you guys today? There we go. I just wanted to hear a big room say hi. So you're here for breakout session 1323. It's all about some best practices around the virtualization of Active Directory. My name is Chris Skinner. I work for VMware. I've been with VMware for about 3.5 years now. I'm a senior technical instructor officially. I work in the PSO education group, and this topic comes up a lot with clients, and it comes up a lot with our students that are in class. How do I virtualize? What do I need to know about virtualize? Can I virtualize? All that fun stuff. And what the attempt of this presentation, my goal is to, over the next 50 minutes or so, kind of get addressing the points that you need to understand about the virtualization process. We've got a series of slide deck here to go through, and we'll try to cover all the big points as we get in here. Regarding the questions and answers, since there's so many of you here, what I'll probably do is just step off the stage, off to the side here, and then you can, for as long as they'll allow us to stay in the room here, answer me with some questions. If you see me in the hallway, you're welcome to stop me. If you come over to the VMware booth, you'll find me there. So any number of places, I'm sure you'll be able to shag me down and corner me about these questions. The presentations, for those of you that attend, will also be available. So all the information in the slide deck that you see and things like the registry settings that we're going to be talking about and so forth, they'll all be in printed materials after the fact, so you don't have to go crazy writing notes down and all that fun stuff. So, okay. The disclaimer, which I'm sure if you've been to any of the breakout sessions up here, is pretty standard fare. We're putting this up. I'm sure you've all read it. Next slide. So our objectives and goals. What am I trying to accomplish with this presentation and this discussion? The first thing is you can virtualize Active Directory. It can be done successfully. We have tons of clients that do this. Home base for me is Chicago. It's the third largest city in the country. We have lots of Fortune 1000 companies that are doing it and doing it successfully. So it can be done. The other important thing is there's nothing mystical or magical about doing it. You don't have to be Mr. Wizard to make it happen. We're going to look at some of the things that you do have to be aware of and some things that you have to be careful about when you go through the process, but it can be done. There's nothing scientific about the process. Many companies have already done it, as I've said. Many of them are actually doing it fully virtualized. We do have clients that run in a physical and virtual mode. A lot of that has to do with the fact that there's the fear, uncertainty, and doubt about letting go completely of my physical machine. We actually have some that have just cut loose and gone completely across the board and done the virtualization 100% of the way. So what's the agenda of this presentation? Ultimately, what am I trying to accomplish with this slide and impart knowledge onto you? Number one, you're going to ask the question, why should I virtualize in the first place? You know the old saying, if it's not broken, don't fix it. So what do we gain by actually going down the virtualization route? And hopefully we'll get an opportunity to address those issues as we go through it. What do you need to watch out for? What are those road bumps that I keep talking about? What are the challenges that I might be facing as I do this virtualization? And what do I need to be careful for? And we'll, of course, address those with some slides, too. Lastly, how do you get from point A to point B? How do I get from the physical world to the virtual world in a successful way? How do I wean myself off the physical dependency and allow me to get into a virtualized world? So let's start off with, why do I virtualize? Why would I do this in the first place? Well, standard virtualization concepts, VI3, of course, is our product line to address this, but hardware consolidation, eliminating server sprawl. This is the thing that used to be the big thing 3.5 years ago when I started working for the company. It was all about doing the server sprawl, controlling that server sprawl and getting rid of those number of physical servers. And of course, now that we have solid, robust virtualization platforms, we've now introduced a new word, which is virtualization machine sprawl. So we've gone the other way with it now, but basically, we're taking these single-use boxes and combining them into packing them densely onto a fewer pieces of hardware. You all know about that. Another really nice thing with regards to domain controllers is the standardization of a virtual machine. As you know, it's a standardized set of hardware. So regardless of what box it goes on, it can run because it's the same set of hardware, no matter where we put it. And of course, that gives us, as a virtualization concept, much greater flexibility as we go through this. Product activation issues, for those of you that are not running any running license versions that require you to activate the product from time to, some of you aren't, but some of you that might be doing that, of course, if you move hardware around too much or change too many pieces of hardware, you of course may be looking at a reactivation situation. That of course becomes a moot point with a virtual machine because we never actually change any of the hardware. The only component that's presented to a virtual machine that could potentially be different is of course the processor. Lastly, you can leverage off of several of our VI3 features, DRS, HA for high availability solutions, VCB, which of course if you're using VMware's consolidated backup, integrated with some of your third-party commercial software, you can use it in a very, very nice way for backing up virtual machines, Active Directory databases. So additionally, we could use it for test and development. We actually have a lot of clients that are using this for migrations, or they're looking at it as a mechanism for being able to consolidate or re-architect their domain infrastructure. Where it's become so many different domains, this is a way to look at it as a mechanism for doing it in a test and dev environment. They also have policies that they want to test, but they want to do it in a controlled way that they don't actually have to implement that policy in a physical world to their client machines in a production environment. They want to do it in a virtualized world so they can control it and not present it. And of course, with fewer hardware allows me to do that. Migration, upgrade testing, as I said, reconfigurations, different types of deployment scenarios that you might use, testing different disaster recovery solutions that you might have as well. Security controls. One of the things, of course, is a virtual machine, since it's not a physical entity itself, it's actually a software representation of a physical computer, we have fewer pieces of hardware that we have to control access to. And simple math tells you fewer number of boxes equals less risk, because you've got fewer machines that you have to maintain or be careful about restricting access to. This, of course, limits some of the physical access. Virtual Center as well as ESX Server both have some additional levels of control, permissional control that we can implement on virtual machines, aside from the traditional three-finger salute logon. We have the ability, of course, to implement access policies, which as an administrator, you can actually control who has access to virtual machines or not. It also gives you the opportunity to separate away applications from a domain controller. And this is usually the case that we find in most small to mid-sized companies, where just from a dollars and cents standpoint, resource standpoint, they don't have the luxury of having the traditional mantra thing that we all grew up on, one app, one OS, one box. We all grew up on that. You know, Microsoft does tell us that as a best practice, you should run applications separately on different machines, although technically, you could run SQL Server on a domain controller. You could run Active Directory and Exchange on the same box. They tell you that's not a good idea, and it makes sense, but a lot of small to mid-sized companies don't have the luxury or the resources to have all kinds of different physical servers to do the separation. Virtualization, of course, gives them the opportunity, Microsoft licenses notwithstanding, but gives them the ability to separate out these components and still be able to run them on fewer pieces of hardware. So that's one of the advantages from that standpoint. So what are the major challenges that you're going to face as you go through the virtualization process of Active Directory? Probably the biggest thing and the biggest challenge that you should be aware of is time synchronization. It's a very critical component to Active Directory, as we'll see when we go to the next couple of slides here, but it is definitely something that has to be carefully planned for. It has to be carefully monitored, and we're going to look at how we can do that successfully and what your choices are to do that. Performance is another issue. Occasionally, we get clients who will tell us that virtual domain controllers don't perform as well as physical domain controllers. That was an interesting comment that we've heard from several people. So a couple colleagues and I actually put that to a test to see if that was really true. And the results might surprise you a little bit, actually. The other big challenge is, of course, replication. Active Directory needs to be able to replicate those update sequence numbers successfully among their domain controllers. And there's all kinds of things that could go awry to prevent that from happening. And of course, we want to look at how we can build reliable replicating infrastructure in place for the updating of these records as they get changed in the Active Directory domain controllers. High availability of the domain controllers. Of course, nothing would be worse than to completely virtualize your Active Directory domain controller infrastructure, have all those domain controllers in the virtual machines reside on a single host, and then poof, the host goes away. That would be not good. Guaranteed you'll get a phone call or two from somebody if that happens. So what do we do, or what kind of things can we implement in place to avoid that single point of failure? Lastly, what are the DR options? There's definitely some things about Active Directory that you have to be sensitive to with regards to backing up the data and restoring that data and being very smart about what the implications are of using different methods of backing up Active Directory. Time synchronization, let's talk about this first one here. Probably one of the most critical things to think about when you're working with Active Directory and you're looking at how do I build a solid infrastructure for this. And as we go forward here, oops, there it is. Why is it so important? It is extremely time sensitive. AD, if you didn't know that, is based on Kerberos version 5 in its current incarnation. I'm actually speaking to Windows 2003 for the most part in this presentation. But it is a 5-minute tolerant window, as you can see in the graphic that's on this slide here. And that means that virtual domain controllers or any physical domain controller has a 5-minute skew. And if those virtual machines or those physical servers become more than 5 minutes skewed from each other, all kinds of nasty things start happening. For example, logon authentications are denied, tickets begin to expire, it refuses any current logon requests, all kinds of interesting things. It stops replicating records to the other domain controllers in there. So time sensitivity becomes a very, very important component as we go through this. FRS, which is the engine that Active Directory uses to replicate all of these records that get changed, is, of course, all those records reside in that sysvol folder, which is very important to that. And FRS's purpose in life is to make sure that we are currently replicating all of those records around. Some of you in this room here might not be even old enough to know NT4.0, but NT4.0, which Microsoft told us was a scalable Active Directory solution, did have one unique element about its structure. There were two types of domain controllers, primary domain controllers and backups. And the fundamental difference between the two was there was only one PDC and as many backup domain controllers as you felt necessary. And the fundamental difference between the two was the PDC was the only one that had a read and write copy of the database. Backup domain controllers read only. They took all their direction from the PDC. That introduces a single point of failure. So Active Directory, of course, makes every single Active Directory domain controller a read and writable entity. And of course, that means that records, in fact, could be changed on multiple domain controllers. So we have to make sure that we provide good, solid time synchronization infrastructure for those domain controllers to be able to replicate their individual changes with the others. So the time server hierarchies, the reason for this graphic here is to kind of show you the relationship between who gets their time from what. As you know, it's in English, you can read it. It's pretty self-explanatory when you look at the bullet points there. But the idea is to make sure that you understand what the hierarchy is. And one of the 5 FSML roles that exist in every Active Directory domain or domain infrastructure is the PDC emulator. And the PDC emulator is the master timekeeper for that domain. And one of the more important, aside from doing several other things that the PDC emulator is responsible for, not the least of which is providing a PDC for 4.0 domain controllers, and of course making sure passwords get replicated and so forth. It does a lot of other things, but the PDC emulator's job is also that entity that's responsible for keeping time. And one of the things that you need to make sure that you consider is the PDC emulator for the master forest root domain. This is the master timekeeper for the entire forest. So that's the one that you want to focus your energies on, certainly when you look at the time synchronization for your entire forest. So the challenge becomes, or the issues associated with virtualization, come with this first bullet point here. The key is that you need to remember that a virtual machine running on an ESX host on our hypervisor, if it does not need CPU cycles, it doesn't get CPU cycles. If it's not in demand or asking for CPU cycles, it's not getting it. Well, in general, from your A+ Hardware 101 training, operating systems keep their time by, during the post-process, an interrupt timer is set based on the CPU cycles. And the OS uses that to process time ticks on a regular basis based to that clock cycle. Well, as you can plainly start to realize, a virtual machine that doesn't need CPU cycles isn't getting CPU cycles. And if it's not getting CPU cycles, that means that the timer ticks start to backlog. And as they start to backlog, the problem that you run into is if they backlog more than 5 minutes, what happens is they stop communicating with their replication partners, and all the time problem for Kerberos starts to rear its ugly head. Clock drifts can be pretty significant in a very short period of time. And so one of the things that Bullet says here is idle cycle times are the enemy to Active Directory. Of course, that means that if a domain controller does become inactive or doesn't need cycles, it could drift very quickly. And so how do you go about doing that? Well, what we actually did here, as you can see, there we go, let's flip that again, is we ran a test. And we ran a test in which we beat up on some domain controllers running on a host that was not using any time synchronization. And we stressed the other virtual machines on that same host, and in 18 hours' time, we had 28 minutes of drift. Of course, it's a moot point after 5 minutes, but it can happen extremely fast. So the problem on the table is the time synchronization issue. The next question, of course, is what do I do about that? You have a couple of options that you can go after for this. Option A is to use Microsoft's Windows Time Service. Perfectly acceptable solution. They have a published document on how to do this and the parameters that you can use to control this. I've actually even listed them as a link in this presentation at the end, so when you get it, you'll be able to find where these settings are defined. So the option A is to use Windows Time Services native to Windows and not use VMware tools. So what we do is we simply identify an alternate external time server. Many of you might already have time servers in your shops already, and you can use those, perfectly acceptable. But what you want to do is you want to choose a reliable Stratum server, Stratum 1, Stratum 2 server in there, the most trusted time servers, and modify the registry entries on the PDC emulator. And you can see that the first parameter that we're in here is we're changing it away from its default NT5DS setting to NTP. NTP is, of course, the network time protocol. And the second variable that we need to modify in there is to define what it is we want that variable to look at for a time source. In this particular example here, we're using, you can use anything you want. You can change it to something, the example I hear is TOC, USNO, Navy military time clock. You can use IP addresses, that'll work as well if you don't want to use fully qualified names. However, the caveat is if you do use fully qualified names, you need to put that hex parameter in the back end of it as you can see. You can also, and the knowledge base article that Microsoft has that I referred to at the end will actually tell you that as well. You can also list more than one time server. If you don't want to put just one, you can comma separate the names in there as well. The next is the announce flags variable that we see. The announce flags variable, by changing that to a lower value, is basically a variable that says, is this a reliable time source server? And of course, by lowering the value here, we're of course identifying this as a lower priority time source. Restart the service, and then of course, the last command that you see in the slide is a manual resync. So we're manually resyncing the time. So that's option number one. That is basically not using a VMware solution, but using a tried and true tested method that works with Microsoft's time services. The second option is to not use Microsoft's time services, completely ignore it, and use VMware Tools time source. This option is modifying, again, the same parameter, but instead of using NTP as the variable in there, we put in the variable no sync. And putting that variable in there, we then turn around and we enable in the ESX server itself, we turn on the daemon and set it up to do external time synchronization. Now, we have a document on this one here that we have, the knowledge base article here. If any of you are on the .5 or greater release, you know that we also can do that through the GUI now. In the past, anybody that had a .0 release, you would have had to do that from command line. Now with the .5, you can do that through the GUI in there. So essentially what we're doing here is we're forcing the ESX server to become an NTP client to some external time source. Then we check the box, which is not selected by default in the guest. And the reason that VMware does not check that box by default is because we have no knowledge of what's going on in that guest. So therefore, we don't know if you're running NTP services in that guest or time services, so we don't select it automatically. Check that box. When you check that box, if many of you don't know this, VMware Tools forces the guest OS to check in with the service console at least once a minute. And of course, by running it at least once a minute, we're forcing that guest to process CPU cycles, which eliminates backlog of timer events, in which case we don't get behind. Then the important thing to realize with this VMware Tools as a strategy or a solution is VMware Tools as a tool set for the guest OS it's not ever been designed. It assumes that the guest is always behind in time. It was not designed to allow guests to slow down or throttle back. So one of the things that if you have guest OSs that actually get ahead of time, this isn't going to solve your problem. VMware Tools is not going to slow it down. So that's a misconception a lot of times that we hear from clients and students about that. Make sure that you understand that the fix to that is to change the time to something correct or slower and let it catch up. So that's actually this last bullet I just didn't click on here. Okay, there's essentially your two options in here. There's also another mechanism. I don't know how many, is anybody curious, anybody in here actually done a custom installation of VMware Tools? Yeah, everybody just clicks through the typical thing and go. There's actually a customized installation, and there is a component in there called the descheduled time accounting. And this actually does a couple things. Number one, it installs a process into the guest OS, which you can then monitor with any time monitoring tools or performance monitoring tools or anything that you want. It adds a service to it called the desched time accounter. And essentially what this thing does is it's actually a little bit more efficient way of managing time for the guests. Now, unless update 2, and I have to be honest, I haven't looked at update 2's tools install yet, it's not installed by default. And what this actually does is it will do a much better job of managing and controlling those backlog timer ticks. Good question. You know what, let's take that offline at the end so I can get through the end of this here as well. And then just grab me up here off the side. So it actually launches a thread within that, and it's going to be single-threaded because it's only supported for uniprocessor VMs anyway. So if you're going for a multi-threaded solution, but we'll talk about multi-processor VMs and domain controllers here in a few minutes as well. Okay, so there's if you've not ever seen it, here's a graphic of where you find that. Just if you do a customized tool set, you know, if it's got a red X on it, that clearly means it's not been installed. I'm going to hold the questions for just pull me over here to the side at the end. And then you choose that in the drop-down box and say install that tool, and we'll go for it. So here's the key. The key is simple. Use one or the other. Don't attempt to use both. If you try to use both, you're going to end up with the VM flip-flopping in time, and that becomes a problem. You'll confuse the virtual machine in its time. There'll be some really goofy things going on with the timestamps of the records that you're trying to update if you allow it to flip back and forth between the two in here. What choice you make, that's entirely up to your organization. Technically, either one is supported. Technically, either one works. VMware obviously would like to be in control of this process by the VMware tools, because if you use Windows Time 32 or Windows 32 Time Service, remember that VMware has no knowledge of what's going on inside that guest, inside of a virtual machine. We don't attempt to monitor what's happening in that guest, so we don't really have any control over that. So either method will work, and I know you've all been in the industry long enough to know, and I say this all the time, you all should know the 7 layers of the OSI model, right, intimately by now. This is layer 8. This is the political layer. So this is that layer that you guys need to sit down and figure out how are we going to do this. So the next one that we look at are some of the performance issues. As I mentioned on the outset here, we actually have a fair amount of clients that have some sort of misconception or understanding about the performance of a virtual machine that's running as a domain controller or a virtual machine running, or excuse me, a physical domain controller, and somehow under the assumption that it's going to perform a lot slower. So we wondered that too, put it through a battery of tests in here. A couple things that came out of this. Well, first of all, this is a given, the first bullet point here. What that first bullet point's attempting to say is, if you are going to run any virtual machine on top of a hypervisor, there's overhead. There's no way that you're going to be able to produce or present to a virtual machine running on top of another layer 100% of the capacity of that standalone physical machine. It's not going to happen. The overhead to manage that as a virtual machine is going to consume some of that utilization, some of that capacity. So at some level, virtual machine domain controllers, though, should easily be able to run at 85 to 90% of the physical machine's capabilities. Interestingly enough, in most AD deployment data centers, virtual machines never really consume more than about 10% of their processors anyway. And it isn't, the thing about a domain controller is it's not really CPU intensive as an application, certainly not compared to others like Exchange or SQL, but it is more memory intensive than it would be CPU intensive. So that's something to think about. And we have found that in most cases, domain controllers that run as single processor virtual machines perform as well as a virtual, they don't really gain much by running it as a multi-processor virtual machine, unless you're running something else on that thing. But if you're running it strictly as a domain controller, since domain controllers are not CPU intensive, you need to be more concerned about the memory side of the house. We've got some slides to address that a little bit later on as well. The other item here says, requires less significant hardware to achieve a greater number of virtualized domain controllers. What we're trying to say there is that because it doesn't use a lot of the CPU's resources, you should be able to get more virtual machines on that single physical entity and therefore, of course, raising the utilization of that physical machine, which is ultimately what we're trying to do with virtualization anyway. And of course, the more domain controllers that you can present, the greater the experience and logon capabilities that users will have, of course, because they've got more boxes that they can log on and authenticate with. Okay, so we actually took the numbers to a test, and we looked at some of the basic tasks that are performed on domain controllers. Adding users to the domain, searching Active Directory for some sort of an object, making changes to users, logon authentications that are presented to the domain controllers, searching for something in a GPU policy search to apply. And as you can see here, the numbers are kind of not really relevant per se. What we're trying to show you is that the same physical entity that we then turned around and put the host on, ESX server on, and ran a single virtual machine domain controller on there so that we were comparing apples to apples, you can plainly see that they run fairly neck and neck to each other. In some cases, the virtual machine might even do a little better in some cases. But notwithstanding, they are not in fact performing significantly better than a physical standalone virtual machine is. When we scale that to 2 processors, we don't even see that much of a change. Although we do see performance increases for sure, we definitely don't see a really lopsided comparison between the two. And then the third slide is, well, we wondered about scaling up. What if I had a physical box that ran 1 processor and then I added 2 processors to it? And the same thing for a virtual machine. And you can see that the scaling performance factor fairly kept, well, neck and neck as it went up in the increasing or the scaling category of this. So ultimately what we came away with, it was a really hard statement to say that virtual machines do not perform as well as the physical servers. And specifically from the AD perspective, that doesn't just hold true anymore. So obviously it doesn't necessarily, virtual machines don't necessarily increase performance by any stretch of the imagination. We've never said that. Remember, the whole concept of virtualization is not to make something run faster. Well, of course, if you're bringing it from your 386 DX25 to an HP DL585, I would expect it to run faster, of course. But apples for apples, we're not trying to run things faster. And as I always say also, remember the days, again, some of you don't remember the days of the computers that had the turbo button on the front of them? That's not what we're doing here. We're not pushing a turbo button on these machines and trying to overclock these suckers. Some of you are old enough to remember those, okay. Or memory in a tube, yeah. So the other thing is, so proper planning of resources is still important. You still have to do resource allocation. Build resource pools that are, of course, going to carve off allocated chunks of resources that we can distribute to the domain controllers specifically for their use. And of course, there will be plenty of presentations this week to get into the concepts of resource pools and distributions. Don't ignore Microsoft's best practices around the FSMA role placements. You should still consider those. We're not doing anything in a virtualized world that should change that behavior. You still have to have the proper number of global catalog servers. You still have to have the proper placement of these roles, where those schema roles go versus the RID master and all those other fun roles that we have in there. Okay, so security network and some replication issues that we get into here. First of which, let's take some of the simple things. I mentioned to you in the outset here that, of course, security, we have a dimension of security that we can implement simply through Virtual Center ESX. Our roles or our permissions permit us the opportunity to actually add another layer of security that isn't otherwise available on a physical machine. So from a virtual machine perspective, you do have the ability to actually, if you don't find a predefined role that works for you, then we can create a custom role. That's certainly one of the really nice things of Virtual Center 2.0. If anybody in here worked with Virtual Center 1X, you remember you had 4 roles that you had to live within, and you had to find one of those 4 roles to work with. Now we have customizable roles that you can use. So obviously we can apply those or add that layer of security to your environment as well. Network connections, as you all know in VI, we have the graphic maps that will allow me to show the interconnectivity between the virtual machines, their data stores, and the networks for which they see access to. So obviously communication for successful FRS replication is going to be necessary. In the lower right-hand graphic you see there, it might make sense to actually not put all of your domain controllers on the same virtual switch. You might segregate them off into different switches so that in the event that something networkable, a network interface should go down, you haven't lost all your domain controllers. Of course, the other thing we'll talk about a little later is don't put all your domain controllers on the same box. And of course, you can mitigate the problem if you do that as well. But the maps view will give you a great visual to show you this. In addition to that, as you know in VI3, we have a bunch of advanced switch settings in here, which will allow me to implement things like NIC teaming so that I can make absolutely sure that I have redundancy from a network interface standpoint so that I don't have single points of failure in my network adapters. And again, it's beyond the scope of what we're attempting to cover in here, and we'll have many presentations this week on network and network redundancy and so forth, and load distribution that we can get, that you can attend and get to the same stuff. It's not really an AD related thing, it's just something to think about as you do your best practices. This happens to be a tool that I think is one of Microsoft's most unsung tools in the Active Directory tool set, RepelMon. Many of you might be familiar with RepelMon. The replication monitor tool actually will show you just a wealth of information. It'll show you who it's replicating with, when was the last time it replicated, is it still replicating with its partners, all of that, what the relationships are in the multi-master replication domain replication process is. So it's an excellent tool for you to use to make sure or troubleshoot if you're having any issues associated with the replication process to begin with. In summary, basically, I would say use some of your access policies to put additional security layers in there. Configure some of your outbound switches for redundancy so that you don't have single points of failure. Make sure that you test, and make sure you're properly getting replicated information between your virtualized domain controllers. That leads us to the high availability, making sure they're always there. And what do I do for disaster and disaster recovery and backing up these Active Directory domain controllers? As you well know, some of you may not yet, that might be why you're here, Virtual Center has a feature called high availability. It is the tool that allows the recoverability of a virtual machine in the event of a catastrophic failure of a host. Imagine if you have all of your domain controllers sitting on the same ESX server and it fails. Now you don't have domain controllers. That's not a good solution. So one of the other issues that you also have to consider is what if it does fail and I have to restart those virtual machines? Remember, HA only recovers or restarts virtual machines that were running at the time of the failure. And the reality is that you want to make sure that these are high priority virtual machines. They are your infrastructure boxes that support your domain and domain logons. It'll be important to identify them as high priority virtual machines, because when the restarting takes place of HA, it will restart all the virtual machines that have a high priority first. It'll prioritize those first. Now, this can be a cluster-wide setting, which is defaulted to medium. And of course, you have the ability to change it on a per virtual machine basis in here. So, and again, I always ask the question in my classes, has anybody ever had the joy of trying to start an Exchange server without access to a domain controller? It's not pretty. Exchange has a heart attack if it can't start up and get going because there's no domain controller to talk to, because it's so tightly wound into Active Directory. So it'll be important to make sure that for situations or configurations like that, that you get those domain controllers fired up before you actually have another issue. The other item here is the isolation response. Up until update 2, which our most recent update, the default behavior was to power off virtual machines in the event there was isolation to that host. Of course, that woke up a lot of people when they had the first time that a junior admin rebooted a switch to all the ones that the ESX server came into. Although VMware tries to pound into your head redundancy for the service console interface, there are some clients that didn't do that. And as a result of that, somebody that bounces a switch causes isolation on every single host, and of course its default policy was power off. Just talking to a client a couple months ago, they had 16 hosts in a cluster, all plugged into the same switch. Junior admin rebooted the switch. Nobody told him. 273 virtual machines. Not good. So what you want to make sure of is, and as of update 2 now, we've actually, when you do a clean install of update 2, we now actually have changed that parameter to leave powered on. So that's one of the other things that you might consider if you're not there yet, or you've made that change away from its default. For virtual machines that are running domain controllers, isolation, failure is a whole different animal, but isolation you probably want to leave powered on. From a high availability standpoint in here, we have rules that you can instigate on HA, DRS clusters, and that is anti-affinity or affinity rules. One of the things that you want to avoid doing is end up with all your domain controllers on a single host. The answer to that, or the best practice solution to that, is build an anti-affinity rule that guarantees or ensures that your domain controllers don't end up on the same host. Of course, remember that the DRS cluster will make its best effort attempt to honor that rule. And the key, what I'm trying to get at here, is if you've got a 2-node cluster and you lose one node, it's going to be very difficult for DRS to honor that rule. Okay? So keep in mind when you start looking at that. This is a discussion that we have with some regularity and some frequency. I've a number of times a client says, should I buy 2 4-ways or 4 2-ways? Well, the simple math to that question is this very scenario here. I always ask back, well, if you have a 2-node cluster and you lose one node, how much capacity do you have left? There's your simple math right there. If you've got a 4-node cluster and you lose one host, right, you still got capacity and still got some redundancy. So when you start looking at anti-affinity rules, those are the types of configurations that you want to think about as you go through that. Now, from a disaster recovery standpoint, just because it's a virtual machine does not preclude you from doing consistent, regular system state backups. It's important to do that. It's very important to do that, because number one, it does several different things, as we're going to see in here. Most of the major commercial software that's out there can do system state data backups. VCB can actually be implemented to do that as well. As a matter of fact, if you guys aren't familiar with VCB, one of the things that I demonstrate to clients and students is that there is a pre-script that you can run prior to the snapshot of that virtual machine. If you didn't know this, VMware Tools has a script that can be executed prior to the snapshotting of the virtual machine before VCB backs it up. And of course, one of the things that I always show them for domain controllers is that pre-backup script that's run by VMware Tools. You simply have that pre-backup script run a system state data backup, so that when it's done, it snapshots it, and then you can grab that system state data backup file from that. It's a super easy automated way to tell VCB to do a system state data backup of a virtual machine before it backs it up. Okay? Great way to do that. Follow the roles, as we said, for the FSMA roles. So I've added the link to where that documentation at Microsoft says about the best practices. And always make sure that you do authoritative and non-authoritative restores for Active Directory domain controllers. It's extremely important that you do that. Bringing a domain controller back from a backup copy that you did using a poor man's backup by shutting it down, copying the VMDK file, and sticking it in your front pocket for 6 months, and then throwing it back on the wire when you have a corrupted domain controller and powering it up is not the proper way to do this. I have heard clients tell me, yeah, I back up domain controllers by taking snapshots. I'm not exactly sure how that's doing a backup of Active Directory database, but I mean, they're looking at that as a logical way to do that, and that doesn't actually do a proper backup of the Active Directory database. This particular graphic here is intended to show you the improper and proper restoration of a virtual machine, and the problem that you run into by doing that very scenario that I just said. That is, by simply taking a backup copy of the disk. There's a parameter called an invocation ID that's associated with Active Directory databases. That's just a fancy word for a revision of a database. And every object in Active Directory has a USN, an update sequence number. And as changes are made to objects in Active Directory, it increments that update sequence number. So life is good if you do, when we start off here, as you can see on the left-hand side, there's a virtual domain controller. On the right-hand side, how the second domain controller sees the revision level of the first one. And you can see that their update sequence numbers are in sync, their database versions are in sync, and then we have a failure of that first one. So Billy goes and pulls out this backup copy that he made 8 months ago of this domain controller, and he puts it back on the wire and brings it up. The problem is it's still carrying the old database ID because it never gets reset through the proper system state data backup. So Virtual Domain Controller 2 still sees the database ID as A with update sequence number 1000. Well, it looks at the other domain controller and says, well, you're still update A and update sequence number 500. Domain controllers are not interested in seeing any changes unless they're greater than the ones they've got. So that means that basically the second domain controller here is going to ignore any changes that go on in the first one until it hits 1001. And it may be a whole lot of changes that are going in there. So you can see that very quickly you get out of sync. Now, if you use a proper method, we reset the database ID so that the second domain controller now sees that it's a different database, means it's got different objects. I need copies of that. And will request or pull those copies from that other database. So this is the danger in using the poor man's backup, which is to shut it down and copy it and put it away for a rainy day. And you can't do this with domain controllers because you'll get yourself into some trouble with the sequencing of those numbers. So in essence here, what we're saying is that use DRS's anti-affinity rules to ensure that you don't have all your domain controllers on one box. Make them high priority virtual machines in the restarting capability so they come back up fast, come up early, in addition to making sure Virtual Center is a high priority virtual machine if you run that in a virtual machine. And use the system state data in here. Again, this default useful life, and this is OS version specific, is going to be dependent on whether it's 60 or 180 days. It just depends because different versions have different tombstone lives. Again, it's going to be, your service pack level will even dictate what that changes as well. I've put the knowledge base article on here. Microsoft explicitly states that it does not support, let's underscore those words together, does not support the snapshotting of any Active Directory domain controller, okay? So you don't want to get yourself into that world. That's not the way that you want to do this, okay? And the placement of the FSMA roles that we talked about. How do I get from here to there? The next is that presentation or that piece of the puzzle here. So there's some things that you need to consider about the VM itself and the configuration of that VM. And of course, there's some things that you can do to wean your virtual machine, your physical boxes or your physical domain controllers into virtual machines. Let's start off with some of the virtual machine considerations. I mentioned to you that CPU is not a super high priority for domain controllers. Memory is a more critical component. Some of the best performance that you'll get out of a domain controller is if you have the ability to load the entire AD database into RAM cache. If you can load the entire Active Directory database into RAM cache, that's where you'll see one of your greatest improvements in here. Some of you might be familiar with the boot INI 3G switch. That opens up user mode memory up to 2.75 gig. That's what that 3G switch does for me. And of course, by doing that, that particular parameter switch setting in there will allow an Active Directory database of approximately 100,000 objects to be stored in RAM. Now, that sounds like a lot to some people. Trust me, in some big companies, that's not very big. And of course, the 64-bit version you can see is also pretty self-explanatory. It depends on the OS and what you're running it on and so forth, but you can see as high as 2.5 million objects. One of the things also about the virtual machine considerations, and I'll show you a link to an AD sizer if you have no idea how big your Active Directory is going to be. So some of the other considerations, any additions or modifications or any searching or deleting operations that you perform are going to benefit from RAM caching because you're doing it in memory. So that's, of course, going to benefit that. There's always going to be some performance hit, whether it's physical or virtual, to actually write it back to the database. Because at some point, those changes have to be written back to the disk, into the database. And so there's always some sort of penalty or hit on that, no matter what, whether we're talking virtual or physical. Microsoft makes a tool available. There's actually several different ones, but Microsoft makes a free tool out there called AD sizer. And it's just a mathematical calculator allow you to drop in. This is how many users I think I'm going to have. This is how many groups. This is how many nested groups, computer objects. And it'll actually generate an approximate size of your AD database so you can get a gauge for how big you think that thing's going to be. Microsoft's best practices about separating the disks also should be followed because a virtual machine can have multiple VMDK files. And if you can do that, it's always a good idea to separate them. We can have up to 4 SCSI controllers, and each SCSI controller can have up to 15 devices. So you can certainly separate those things out. Getting from here to there. Start with a fresh backup. You know what the old saying is, never start anything without backing up first. That's the first order of business. The next is, of course, consider using a dedicated switch, virtual switch, or virtual machine port group on a switch to be more accurate, for isolating the replication traffic. If you have a large AD infrastructure, this could take a while, okay? It is always a good idea to let this thing stabilize for about 24 to 48 hours. Give it time to be able to get all of those records in. And we are talking about replicating from your physical world into your virtual machine. And you might want to do that on its own network if you have the luxury to do that. Next, of course, is that I've said already, generally, this isn't across the board, but generally, single processor virtual machines are more than adequate for domain controllers, unless something else is running in that Active Directory domain database. Validate, make sure you use Replimon to make sure that your inbound, outbound replications between your physical and virtual machines are in place. Allow 24 to 48 hours to replicate. Then we can do some clever things with the DNS records. The DNS records are a great way to modify or wean your users from logging on to those physical domain controllers and start directing them into the virtual domain controllers. And by doing that, you of course can take some of the load off the physical boxes, so ultimately you can deprecate them or get rid of them in their process. And of course, make sure that you monitor logon events. decommission your physical domain controllers when all is said and done and life is good. Your DNS modifications, transitioning very quickly. There is a weight and a priority associated with DNS SRV records. Service records are basically records in DNS to just advertise various services. And what we're looking at is we're modifying the logon authentication records. And these records advertise which domain controllers users can log on to. And you can change the weight and the priority of these records so that you can make them least likely to receive logon authentications as other ones. So this is a mechanism. As you can see, there's a couple registry hacks in here, the registry settings that we can do in here. And the first one, of course, is the DNS weight. It's a proportional distribution of requests among the DNS servers. All DNS servers are created equal. That means they all have an equal weight. And since they all have an equal weight, they can all receive logon authentications equally. If you modify the parameters, as we're suggesting here in the slide, you can change the priority of them as they are relative to other DNS servers out there. Likewise, we can also change the priority setting in here as well, which is going to increase the likelihood that it will receive a logon request. And you can see that you can inflate that to an absurdly high number. Its default is 0. So if you change it to something like 100 or 200, now you've changed the weight of that to give it a greater likelihood that it will receive a logon authentication. A domain controller can get a logon authentication. And PDC emulators, since they're doing so many other things in the world, is one of those servers you want to target logon authentications away from if they don't have to do that. So this is a way to prioritize which servers are getting these logon authentication requests. This is standard Windows modification 101. It can be done through the registry, or you can do it through the GUI, either way. If you go into the registry, it doesn't require a reboot, so you don't have to reboot the server to affect the change. If you go into DNS Zone, you can just double-click the object, the service record, and you can see the priority and weight fields listed here. And you just simply put in what the appropriate value is or what you're trying to attempt to do. Avoid snapshots of redos of a domain controller. In fact, I would be very careful about doing that. The exception to that is if, in fact, you're using VCB to back up the Active Directory database. But remember that VCB does snapshots, mount, backup, unmount, and commits the snapshot. So it does that all in the automated process. Don't use snapshots as a mechanism for backing up. And in fact, as I mentioned to you earlier, it isn't even a supported Microsoft solution as a mechanism. Again, the Update Manager does exactly the same thing that VCB does. The Update Manager simply snapshots it, does